Hi everybody, we're going to review for 1-8 and 1-9. This is just for math. So we'll start with 1-8 and the place I'm at in your textbook is on page 115 or yeah 115. And you can see where we're starting to prepare solutions for dilutions and we're going to start with the calculation for a proportion to make dilutions, and you see the formula that's listed there. Actually, I don't know what's exactly happened or why, but notice in the at the top there the fraction was a over a plus b equals c. Well, it's really, if you look down in problem A, it's really supposed to be c over a plus b. Okay, so let's use the problem A that they've given us to use this formula. Um, Anytime you see parts of this, parts of that in a word problem or a formula, then this is going to cause you to or make you think, oh, I need to use this C over A plus B equals V, or what, just to find what a part is. Okay, so you'll see that um, the problem says it's the buffers made by adding 2 parts of solution A to 5 parts of solution B. Okay, so got parts of A, parts of B. So what you're going to do is plug those numbers in. If you go to the solution just under that formula, you'll see we put 2 parts of A and 5 parts of B. Okay, so the total volume required is C, and that's going to be 70 ml. See how they've put that together? So you add 2 plus 5, which equals 7, and then we divide 70 by 7, and that's going to give you your 10 mLs. That is what one part is equal to. So we've calculated a part. Now this formula wants you to use 2 parts of something and 3 parts of another thing. So since we know what a part is, we're just going to multiply. If you need 2 parts and it's 10, so it's 2 times 10. Or if you need 5 parts of something, so it's going to be 5 times 10. And you notice how that's going to equal to your total volume required, which is the 70 mLs. Okay, so in these uh, word problems, as I said, that ask for parts of one thing and parts of another, this is the formula that you're going to use. We'll put this formula up on the chalkboard for you to use as a reminder that this is for proportions. Now, the one where we're going to dilute a concentrated solution is just below that, and you see in the reading above that it's a C1, V1, C2, V2 calculation. And this formula is very, very commonly used in chemistry to figure out how to make a dilution of a solution. So let's go to the word problem B. This is the best way to learn math, is practice it this way. And the word problem asks us to prepare a zero point 0.1 mole of hydrochloric acid using 1 mole of HCl. Okay, so 1 mole of HCl is a higher concentration to the zero point 0.1. We're going to dilute it down to zero point 0.1, and we need a total of 100 mLs. Okay, so the C1, that C stands for concentration, and the V stands for volume. Okay, so C1 is your first concentration or your initial concentration, which is the 1 mole. Okay, you see in the solution they put in the 1 mole. That's the highest concentration. C1, if you kind of think about that C1 being an I, or use that I for initial concentration, what you're starting with, the first thing you're starting with as a memory jogger. Okay, so you just have to figure out which is the highest concentration. Let me plug that number in there. All right, so it's 1 mole. Now, our unknown is the volume that we're going to add to it. All right, so that's V1 is going to be a blank space. It's going to be an unknown. Now, you notice these two things are in parentheses in your text in the solution part. 1 mole times V1. All right, the C2 is your second concentration, and the V2 is the second volume. All right, now the V1 is the unknown and the V2 is known. The volume of, and you know what, I just now noticed they've got this all flipped around too. Either way, concentration, the second concentration should be the point 0.1, and the volume is going to be your total volume, which is 100. Okay, so you see the solution. Let's go down to the part 2 of the solution, because as I said, we're trying to find V1. So algebraically speaking, we are multiplying 100 times a 0.1, and we're going to bring the 1 over and make it into a fraction. So multiply those, divide by 1 to give you 10 mLs. That's your unknown. Really, this calculation's better explained as we're doing it in class. We are going to do this in class, so hopefully this will be more clear as we do practice problems on Thursday of this week. Let's see, ratios. Okay, ratio of a solution. If we look, let's see where ratios at on in your textbook. Okay, so ratios are on the still on 115, and the ratios are fairly simple to determine. It's more like thinking of as a serial dilution. So if you have one part of this, one part, let's just say one part of patient samples, patient sample, and you have 9 parts of a diluent for that patient sample, the end result's going to be a 1 to 10. Okay, 1 part patient, 9 parts of diluent is a 1 to 10 dilution. When we're going to make, let's just say 10% bleach solution, I don't know if that's the best example to use, this which I don't think. Oh, my 10% bleach solution isn't a very good. That's better used for a example for preparing percent solutions, but it's very similar. So when you're preparing a ratio, or when you're given a ratio, 1 part patient, 9 parts of a diluent, that's a 1 to 10. If you had 1 part patient and 14 parts of diluent, that's a 1 to 15. You see where I'm going here? So that's how you would figure out a ratio. So if you were given 1 parts of this, 9 parts of that, it's going to be a 1 to 10, 10 making up the whole. Now, I don't love the problem for solution on how to prepare percent solutions. Problem A, or weight per volume. We're not going to give you any kind of weight per volume solution, or a volume or a weight. And as a matter of fact, I might just take this percent solutions off. But if you were going to say you needed a 10% bleach solution, and the way that you would simply make that is you'd add 10 mLs of bleach and 90 mLs of water or diluent, and that's going to give you a 10% solution equals to 100. If you were going to make a 10% solution and you needed 500 mLs, then you would just take that 10 mLs that you were going to do for the 100 and multiply times 5. So you would need 50 mLs to make of bleach, and add that to 450 mLs of water. Again, we'll work with percent solutions when I see you in class. And then the rest for this, you guys just memorize. These are definitions in your glossary. You need to know what a titer is. Um, and then you also need to know the definition of a solute and a solvent. Okay, on to 1-9. 1-9, I do have a whole entire lecture over 1-9, that I can post for you guys. However, I'm not going to make you calculate a standard deviation. We are going to practice it in class, but I'm not going to make you calculate it. So again, make flashcards, know the definitions, what a coefficient of variation, what the word accuracy means, uh, what precision means, what a mean is, which is an average, trend and shift, what the difference between a control and a standard, and then know what Westgard rules are. You are going to have to complete a Levy-Jennings table, and we're going to do that in class. So that'll be easy to practice. And then you're going to have to calculate a coefficient of variation. So if you go in your textbook, yeah, to page 134. At the top left, you're going to see a Levy-Jennings quality control chart, and that's the same thing I'm going to give to you on your test. Very similar. I'm going to give you control values, and you're just going to have to plug in the chart on the chart each day what the control values are or were. We like to use these Levy-Jennings charts rather than just look at a list of numbers because it's easier to identify if a control value is starting to trend or if there's a shift in the controls. I'm not real crazy about the terminology they use for a shift in a trend. Let me see. The textbook says I'm going with shift now. It's an abrupt change from established means indicated by occurrence of all control values on one side of the mean. That's not too bad. So what that means is go back to page 134. You see that heavy dark line that's going through the Levy-Jennings chart. That's the average or the middle or the medium for that particular control. All right. So when control values are falling just on one side of that means there's a shift going on, because what's normal is control values should fall on either side of the mean. You might have 2 or 3 days where it's on one side of the mean, and then you'll have a couple of days or even a day where it falls on the other side. So that's what your technicians are looking for when they print these Levy-Jennings charts out, on a frequent basis. I don't know if they do it by week. We always did it by month, or if we started to notice, change in values in our controls. We look at this Levy-Jennings chart that our analyzers produce, and they're going to show us if we're noticing a trend or shift. Now, so a shift again is when all control values fall on one side of the mean. If what is normal it's supposed to be on either side. And then a trend is where the controls are going to drift either upwards or downwards for 5 consecutive runs. So let's just say that, go back to your Levy-Jennings chart, that you're plugging these in day after day and it's up, 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 for 5 to 7 days or however long they said in the beginning, or vice versa, it's going down, down, down. Knowing that control values are supposed to fall on either side of the mean, we start to notice, okay, well, this is a trend. Okay, so that's the difference between a trend and shift, and that is how we use the Levy-Jennings chart. Now, when we want to talk about accuracy and precision, you can use page 131 as an illustration. And I like what the textbook uses, and as far as how to identify what's accurate and what's precise. But if you notice box A, the target value, all your control runs or your patient runs are very close to that target value, so that means they're accurate. And then precision means that's letter B, that's where you're going to have control values that are close to each other. They're not close to the target, the center, but they are close to each other. That is the definition of precision. If you look at the reading accuracy and precision and look at what they're saying here, giving you examples of you have these control values that do blah, 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 this, that, and the other, one, two, three. And so it gives you a really good explanation of that if you read that. Um, and then for a mean, standard, Westcard rules, guys, just go ahead and use uh, the your glossary as a reference for that. Westcard rules are the rules we follow that were